In this video, we're going to see how to put a matrix into reduced row echelon form. First thing we're going to want to do is to have a 1 in the upper right hand corner. Now in this particular matrix, there's several ways we can do that, but the easiest one that I like to do is to just swap those top two rows. So we'll swap row 1 and row 2 here. That gives us 1, 2, negative 3, 2, 2, 4, negative 6, 0, negative 1, 1, negative 3, and 1. I'm going to go ahead and circle that 1 because it's where I want it to be to help me keep track along the way. Now that I have a 1 in that pivot position, I want to try and make zeros above and below it. So in this case, that just means below it. So to make that 2 below it into a 0, we can take that row 2 and we can subtract off 2 row 1s. That'll make that 2 in the first column into a 0. So our first column, or first row rather, is going to stay the same. Our second row, we're going to have a 0, also a 0, also a 0. Now we'll subtract off 2 times 2, so that gives us a negative 4. And our third row will remain the same, negative 1, 1, negative 3, 1. Okay. Our first column is almost done. We just need to get that negative 1 in the bottom left to be a 0 as well. So we can take row 3 and we can add row 1 to it. So this will turn into, our first 2 rows will stay the same, 1, 2, negative 3, 2. Our second row, still 0, 0, 0, negative 4. Circle that pivot. Now the bottom row, we're just going to add, so we get 0, 3, negative 6, and 3. So now what we're going to do is we're going to shift our attention to the second row. So we'll come down and we'll go over. And now we're going to look at this spot right here. So this is our next candidate for a spot for a pivot. So we want to make that a 1 if we can. Now, unfortunately, we have a 0 there, which complicates things a little bit. But one way we can get around that is to just swap the second and third rows there. And that'll give us a non-zero thing in that spot we're interested in. So go ahead and write down our first row again, because we're leaving that alone. And now we're swapping those last 2 rows. We get 0, 3, negative 6, 3. And then we have 0, 0, 0, negative 4. And now, one way we can turn that 3 into a 1 is to multiply that whole second row by 1/3. Go ahead and write down the top row and the bottom row, because those aren't changing. We'll multiply our second row by 1/3, so that's still a 0. We get a 1, a negative 2, and a 1. Now we have a 1 where we want to. Now we'll proceed to make 0 above and below it. Lucky for us, there's already 0 below it, so we just have to make a 0 above it. So we'll take row 1, and we can subtract off 2 of those row 2s, so that we can use that 1 in the pivot spot to make things 0. So our 1, 2 minus 2 1s is 0. Negative 3 minus 2 negative 2s is a positive 1. And then 2 minus 2 1s is a 0. That one's still a pivot. Our second row stays the same. And our last row stays the same. So now our first 2 columns are in good shape. So we'll move down a row and move over. And now we'll first look at this next spot over, where we see that's a 0. And unfortunately, we have nothing below us to help. We saw in the previous time we could use the 3 below to turn that 0 into a non-zero thing, but here we're stuck. There's no way to make that a non-zero without going back to the rows above that we had already put into a nice form. So instead, we'll just move over to the next one, and this is going to be our next pivot spot here. We'll try and turn this negative 4 into a 1. So one easy way to do that would be to multiply that last row by negative 1/4. So our top two rows stay the same. And our bottom row looks like 0, 0, 0, 1. So now the last thing left to do is to make sure we have zeros above and below that last pivot. In this case, that just means above. So our last operation here will just be to subtract row 3 from row 2. First row stays the same. 0, 1 minus 0 is still 1, negative 2 minus 0 is still negative 2, but now we have a 0 here. And that last row is the same. So now we see here we have the reduced row echelon form of our original matrix.